Hi everyone, welcome to my channel RDO WORLD. In this particular session, I'm going to talk about evolution of AI models, Gen AI, AI agents, Agentic AI, Multi-Agentic AI, Artificial Intelligence, AGI and ASI. So let's get started. So let's simplify AI once and for all. Because today everyone is using this word Gen AI, AI agents, Agentic AI, but very few people actually explain the difference clearly. So let me break this down in simplest way possible. Think it as a evolution, stage 1, stage 2, stage 3 and go on. So let's discuss about Gen AI, the content creator. First, generative AI. This is what most people are using today. You give it prompt, it gives you output. Input, brain, output. You ask, write me a story, it writes. Create an image, it generates. Write code, it produces code. It's like a super intelligent content engine. But here is the key point. Gen AI does not act. It does not plan. It does not execute tasks in the real world. It responds. That's why I call it the content creator. And that's powerful, but it's still reactive. Now we move to the second level, AI agents. I call it the goal directed helper. This is where things start becoming interesting. An AI agent is not just generating content, it has a goal. For example, book a flight under certain value, let's say $500, okay? Now the system doesn't just write text. It searches, filters, compares, book and gives the feedback. It interacts with the tools. It uses APIs. It loops until the task is completed. This is the shift from talking to doing. But remember, the goal still comes from the user. The agent executes a defined objective. It's autonomous, but within the boundaries. Now we reach the third stage. It's Agentic AI, the autonomous decision maker. This is where autonomy truly begins. Here, the system doesn't just execute your request. It can observe, plan, act, re-evaluate and adjust. Think about a self-driving car. It's not waiting for a prompt every second. It observes the traffic, plans the route, adapts the obstacles, makes decisions in real time. Or a smart factory robot that optimizes production without human instruction. This is initiative-driven AI. Not just reactive, not just task-based, but decision-based. And that's the real leap. So if I summarize this simply, Gen AI creates content, AI agents complete tasks, Agentic AI makes decisions. That is evolution. And most organizations today are still at stage 1. Some are experimenting with stage 2, very few are architecting for stage 3. The question is, where are you building? So in these slides, let's discuss technical architecture, Gen AI, AI agents and Agentic AI. Generative AI is fundamentally a single model architecture. The flow is simple. It's a user, you give the prompt, LLM and response. That's it. There's typically no persistent memory, no tool orchestration, no task planning engine, no execution loop. At best, it may include RAG, retrievals, basic vectors database, prompt templates. But architecturally, it is still stateless and reactive. The LLM is the brain. Everything else supports prompting. If you remove the model, the system collapses. This is inference-based architecture. It generates, it does not execute workflows. Infrastructure requirement, minimal orchestration, mostly API calls to model endpoints. This is why Gen AI is the fast to build, but limited in capabilities. Now let's move to AI agents. Architecturally, this is where complexity begins. The flow now becomes user request, then planner, then tool selection, execution, feedback loop, LLM and response. An AI agent includes a reasoning engine, which is LLM, tool integration, APIs, database, search engines, memory, short term and long term both. A task loop. Here, the LLM is no longer the entire system. It becomes a decision component inside a workflow engine. You now need tool abstraction layer, API gateway, error handling, retry mechanism, state management, logging and observability. Agents operate in cycle like plan, act, observe and adjust. But importantly, the goal is still externally defined. The architecture is orchestration driven. This requires strong middleware, state persistence, controlled autonomy. Now you are building systems, not prompts. So now we reach Agentic AI. This is no longer a tool calling system. This becomes an autonomous architecture state. The flow looks like this: environment, observation layer, context layer, context builder, goal formulation, multi-step planner, execution engine, feedback evaluation, continuous adoption. Notice the difference. The system now includes perception layer like data stream, sensors, real-time feeds, memory hierarchies, episodic, semantic, working memory, planning engine like multi-steps decomposition, policy layer, governance and constraint, learning loop improves from outcomes. Architecturally, this resembles a distributed system with intelligence nodes. This is not a single LLM call. This is event-driven architecture, stateful execution, multi-agent coordination, sometimes reinforcement or outcome-based optimization. Infrastructure now must support persistent context tracking, continuous evolution, autonomous retries, failure recovery, and policy enforcement. The difference is critical. GenAI equal to model-centric architecture, AI agents equal to orchestration-centric architecture, Agentic AI is system-centric autonomous architecture. In Agentic AI, the LLM is just one cognitive model, not the system itself. You can see the comparison which I have shown in this table. If you ask, optimize our cloud cost, GenAI means writes a recommendation report, AI agent queries cloud API, analyzes usage, generates saving plan, and using Agentic AI monitors cost trends continuously, adjusts resources automatically within governance limit. That is the jump. If you understand this architecture difference, you stop confusing a chatbot with autonomy and you start designing AI systems, not AI demos. Now, let's step into one of the most misunderstood but most important architectural distinctions in modern AI: Agentic AI versus multi-agentic AI. At first glance, both sound similar. Both are autonomous, both can reason, both can execute tasks, but architecturally, they are fundamentally different. Let me break this down clearly. So left side, Agentic AI, the autonomous single agent, which I called. Agentic AI is essential one intelligent system operating independent. Look at the architecture. At the top, we have environment, the real world or digital ecosystems. Then comes observation layer, where the agent collects input, context, and signals. Below that sits the reasoning engine. This is typically an LLM combined with planner and policy logic. The single agent observes, plans, executes, evaluates itself, and adjusts. It's self-contained. It's autonomous. It has its own reasoning loop. Now, where does this work best? Enterprise assistants, manufacturing automation, financial analytic bots, focused domain systems. But here is the architectural limitation. There is one central reasoning core, one planner, one execution chain. It can adapt, but its intelligence is centralized. If the task becomes highly complex, cross-functional, multi-domain, requiring parallel reasoning, the architecture starts to stretch. It's powerful, but it's still singular. So now, Look at right side, multi-agentic AI autonomous teams. So which I call that, multi-agentic AI is not one agent. It is a team. Instead of one reasoning engine, you now have a specialized agents. Researcher, coder, validator. Each has a defined role. Each has a specialized objective. And critically, they share memory. This is the big shift. In single agent system, memory is internal. In multi-agent system, memory is collaborative. Now, intelligence becomes distributed. Tasks are decomposed. One agent researches, another writes, another validates, another optimizes. They exchange feedback, they debate, they iterate. This is collaborative autonomy. And architecturally, this introduces cross agent communication protocols, shared memory stores, task delegation frameworks, multi steps collaborative planning, parallel execution. Now compare the bottom section. Agentic AI, single planner, limited specialization, moderate complexity handling. Multi-agentic AI, multiple autonomous planner, specialized role, shared memory, cross agents, feedback loops, high scalability. This is the architecture required for complex supply chain optimization, enterprise strategic simulation, large scale software generation, autonomous research system, AI operating centers. So let me say something important here. Most companies today are still building prompt-based system. Some are building single agent workflows. Very few are architecting multi-agent ecosystems. And that's where the next competitive edge will emerge. Because the real world is not single-threaded. Enterprises are not single-threaded. Problems are not single-threaded. They require distributed intelligence. And multi-agentic AI mirrors how organizations actually work. Departments, teams, feedback, escalation, validation. It's organizational intelligence digitized. So future direction, about if agentic AI is like a brilliant individual contributor, multi-agentic AI is like an autonomous executive team. And as we move toward AGI like system, the architecture will not be singular. It will be collaborative, modular, distributed. That's why understanding this distinction is not academy. It's architectural strategy. So the real question for you is, are you building smart assistants or are you building intelligent systems that collaborate? Because that difference defines scale. So let's talk about AGI and superintelligence. So let's zoom out for a moment. Everyone today is talking about ChatGPT, LLMs, AI agents, but the real question is, where is this all heading? This slide shows the long arc of intelligence evolution. So we started with narrow AI system that could do one thing well: spam filtering, image recognition, recommendation engines, very focused and very specific. Then came generative AI, models that don't just classify but create text, code, images, strategic drafts. And now we are entering what I call the projective phase. AI systems that don't just respond but begin to reason across domain. But the big milestone here is AGI, which is artificial general intelligence. AGI is not just a smarter chatbot. AGI means a system that can match human reasoning across economically valuable tasks. Think about the carefully, not one task, not one domain, across domain. Finance, healthcare, engineering, strategy, negotiation. When AI reaches that dotted line, human level performs. We are no longer automating tasks. We are augmenting intelligence itself. Now look at the curve. It is not a linear, it accelerates. And that's where ASI, artificial superintelligence, comes into the picture. Once a system reaches human level reasoning, something critical happens. Recursive self-improvement, it begins improving itself. And when intelligence improves intelligence, the growth becomes exponential. That's why this upward curve bends sharply. Now let me say something important from experience. Technology shifts are usually slow until they are not. Cloud took 10 years, mobile took 7 years. AI acceleration is happening in 3. Yeah. So the question for leader is not will AGI happen? The question is, are we architecting system today that are future ready for the curve? Because the companies that understand this early will define the next decade. And that's why understanding architecture layers, platforms, orchestration, and governance becomes critical, which brings us to the ecosystem slide. So let's talk about ecosystem, platforms and framework. Now let's move from vision to architecture. Because vision without architecture is just a theory. These slides break down the AI ecosystem into powerful layers: hosting power, cloud infrastructure, orchestration layer, framework intelligence. Let's start with hosting power. At the base layer, AI runs on cloud platform like AWS Bedrock, Azure AI, Google Vertex AI, OCI from Oracle. Each one offers model, hosting, GPU, scaling, enterprise security. But here is the strategic insight. Cloud providers are infrastructure enablers, not intelligence architect. They give you compute, they give you models, they give you scaling. But they don't define how intelligence flow through your enterprise. That's where the orchestration layer becomes the real differentiation. Look at the right side. LangGraph, Crew AI, AutoGen. This is where system move from simple prompting to structured reasoning. LangGraph introduced stateful control flows, meaning workflows remember context across steps. Crew AI introduces role-based collaboration, multiple AI agents working like a team, researcher, analyst, validator, and AutoGen enables multi-agents conversation, systems debating, refining, iterating before final output. This is a massive shift. We are moving from single LM response to orchestrate reasoning system, from prompt response to planning to selection, execution, feedback, adjustment. And here is what 20 years in architecture has taught me. The competitive advantage will not come from which LLM you use. It will come from how you orchestrate intelligence. The cloud layer is becoming commoditized. The orchestration layer is becoming strategic. And above orchestration, governance, memory, feedback loops, autonomy layers. That's how agentic AI systems are built. And if you connect this slide to the previous one, this ecosystem is the bridge towards AGI readiness. So if you are building today, think multi-cloud flexibility, think orchestration first design, think memory and feedback loops, think governance from day one. Because future AI systems will not be single model tools. They will be distributed intelligent system operating across environments. And the architecture who understand this layered model today will be the ones designing tomorrow's autonomous enterprise. So with this particular slide, I'm ending my session. Hope this session is helpful and informative to you. Any doubt, any clarification, please comment me. I will reply. If you like this video, share to your friends. Thank you.